Morning guys, today we're going to take a look at page 14 of the Unit 8 Classwork packet. The goal for today is to use something we learned in Unit 1, namely the Pythagorean Theorem, as well as something we learned in Unit 4, which is that perpendicular lines have opposite reciprocal slopes in order to classify quadrilaterals, alright? So let's take a look together at page 14, example 2. What I've done is I've graphed the figure. You want to do this, okay? You want to make maybe on graph paper or somewhere, but trust me, you definitely want to graph the figure. All right, first things first. My biggest warning to you, do not make assumptions. Let me say that again, do not make assumptions. Just because it looks like something doesn't necessarily mean it is that shape, okay? We always need to prove it before we can actually classify the shape. So, with that being said, let's go. Step 1. Let's start by finding the side lengths and seeing if any of them are the same. The way that we're going to do that is we're going to go back to Unit 1 and we're going to use the Pythagorean theorem on each one of the slanted sides to figure out their length. So, I'm going to do that by making triangles in each one of the corners. Okay, I'm going to do that by making triangles in each one of the corners. Then I'm gonna label how long each one is. So over here, that's 2 and that's 3. This is 3 and that's 2. This is 2 and that's 3. This is 3 and that's 2. Okay? Now, some of you guys may actually see right away that all of these numbers are the same. 2 and 3, 2 and 3, 2 and 3, 2 and 3. And that's gonna mean that all 4 sides are the same. I agree with you, but let's just make sure we know how to actually figure out if this were a perimeter question instead. So the Pythagorean theorem for this side would be 2 squared plus 3 squared equals c squared. That means that 4 plus 9 equals c squared, 13 equals c squared, and rad 13 equals c. Now, if all 4 sides are the same, what does that mean the perimeter would be? Well, the perimeter then, if they ask me for that, would be rad 13 plus rad 13 plus rad 13 plus rad 13. How many rad 13s do you see? That would be 4 rad 13. Okay? However, for the purposes of this problem, I'm just asking you to classify what shape it is. What's the name given, guys, to a quadrilateral? What's the name given to a quadrilateral that happens to have 4 congruent sides? Well, we know that if a quadrilateral has 4 congruent sides, that automatically makes it a rhombus. All right? Rhombus. Okay, so with that being said, I know it's a rhombus, but I also have to make sure to check to see if it's a square. If it's a square, that means it's going to have 90-degree angles, right? And that means that the slopes would be opposite reciprocals. Let's check to see if the slopes are actually opposite reciprocals. This slope over here, rise 2, run 3. So that slope is 2/3. This slope, I fall 2 and run 3. So that's negative 2/3. These are opposites, but are they opposite reciprocals? No. So that means that the most specific name we can give this particular shape is actually a rhombus. All right, and now the way I would expect you to prove that on an exam is to actually show me this work right here with the Pythagorean theorem that all 4 sides are the same. Let's take a look at one more example, okay, just to be safe, and that will be example number 4 on the same page, okay? So give me a moment here to actually draw the figure, and we will get going. Okay. All right. Whoopsie. All right. So example 4 says -4, -3, 2, 3. So right here, 1, -2, right here, 2, -7, 2, 4, 5, 6, 7, and -3, -8. Right, 1, 2, 3, 4, 5, 6, 7, 8, -3, -8. Okay. All right, guys. So once again, I caution you to make sure that you don't make assumptions, all right? Just because it might look like a certain shape doesn't necessarily mean it is. You need to prove it to me by using a combination of slope criteria for parallel or perpendicular lines and the Pythagorean theorem to find side lengths. Step 1, after I graph it, of course, let's find the lengths of the sides, shall we? So what I'm going to do is I'm actually going to draw my right triangles here. Okay? Let me do that. All right, so I've drawn right triangles in all the corners. Now I need to make sure that I label the lengths. So this is 1, and this is, let's see, from -3 over to 2, that should be 5. This right here is 1, and from, let's see, that's at -3, I think, to -8, that's 5. This is 1, right? Yep, and that's, let's see, 1, 2, 3, 4, 5. And this right here is 1, and that's 1, 2, 3, 4, 5. Interesting, right? Very interesting. So like with the previous example that we looked at, all the numbers are the same, as in 1, 5, 1, 5, 1, 5, 1, 5, okay? Still, I want to show using the Pythagorean theorem what at least one of them is going to do. So 1 squared plus 5 squared equals c squared. That means 1 plus 25 equals c squared. 26 equals c squared. Rad 26 equals c. Now, because each of those are the same, technically the perimeter, if they ask me for that, would just be 4 of these. 4 rad 26. So automatically, because the sides are congruent, right? All 4 sides are the same, I automatically know that I have a rhombus. So I'm going to write that down here because I know for sure I've got a rhombus on my hands. But don't forget to check to see if it's also a square, okay? Because a square would be even more specific than a rhombus. The way I do that is by using my slope criteria. Let's check the slopes, guys. The slope here is rise 1, run 5. That's 1/5. The slope here is fall 5, run 1. -5 over 1. The same applies over here and here as well. Are those opposite reciprocals? Yes, they are. So because they're opposite reciprocals, guys, that means that I have perpendicular lines. And what do I know about perpendicular lines? They happen to make right angles. So therefore, what do I call a figure that has 4 congruent sides and 4 congruent right angles? That would be a square. So for number 4, the best answer then is actually not a rhombus. It is a square. Okay? So in sum, when you're asked to classify quadrilaterals in the coordinate plane, step 1, graph the figure. Step 2, find the side lengths, check to see if any of them are the same. Step 3, check your slopes, see if you have parallel lines, perpendicular lines, or none of the above.